Okay, well, I turned on the recording, so welcome to the August 30th, 2022 session of TangerineSDR and HamSci technical session. My name is Dave, KV0S, and this week I've been getting my magnetometer Rev E outside, properly mounted in a tube and connected and running. So I have that running now. I'm leaving my Rev D board running too for a while to get some overlap, both collecting. But that's a major thing. I will say that I had a 3-hour power outage today. So that was not fun, but we're back up and running. I got all my computers working again. So anyway, that's it for me. Next on the list, we have Nathaniel, W2 NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Nice to see everyone this evening. Oh, I see Dev's here too. That's great. Let's see. I have just been super busy. Got started teaching classes today. I'm working. I have made good progress on the white paper, but let's see. I'm still working on it. Just trying to keep everything going. So W2NF, back to net.
Well, fine business. Next on the list is Dev. Joshi, go ahead.
Good evening, everyone. It's been a while, so I thought I would come and just check in with everyone and attend this meeting. I'm doing well in Iowa. I'm working in analyzing Maven data, so making slow but steady progress with my research. Thank you. Back to you.
Very good. And next on the list, we have Jules, K2 KGJ. Go ahead, Jules.
Dave and Annette. Not a lot to report this week. Basically just got out that assembly instruction set on the waterproof connector for the variable RM3100 pipe enclosure, and waiting for feedback on that to see if that's adequate for the hardware paper. Scotty is going to be sending me a kit of parts for the new board and kit of parts, so I can basically do a step-by-step assembly instruction for the hardware paper for that as well. Back to net.
Well, fine business. And next on the list, we have Bill Engelkey, AB4EJ. Go ahead, Bill.
Thanks, Dave. Good evening to the net. Most have been working on the NASA project. I came to the conclusion I need to retrain my machine learning system. So I'm going through and making sure I have a complete set of plots of the spot data. And so that's been, it's been a little bit of a grind. And I realized, it's been quite some time since the beginning of this year since I have updated the database with the new data. So what I'm going to do is I developed something. I'm porting all this software over from C# to Python. I need to do it anyway. So this allows me to bring the new data for the year 2022 in. So I'll be able to test a machine learning algorithm against the newest data and train it with data going into from 2016 through 2021. I'm not necessarily looking forward to all that training because I'm concerned I may get some carpal tunnel syndrome in my hand from doing all the identification of the features in the data. But anyway, that's it's something you just have to do. So anyway, back to net.
Well, very good. And next on the list is David, N1 HAC. Go ahead, David.
Good evening, everyone. Working on our Antarctic power system and pulling parts together with that. And that's pretty much the week. Not much else on the radio front, I guess. So back to net, though. I am wondering if the adapter boards are ready to be beta tested or whatever. Back to
Okay.
that.
Next on the list is James, KG4 DSG. Go ahead, James.
Good evening, Dave and group. Not much to report here. Back to the net.
Okay. Next we have Jim, K4BSE. How are you feeling, Jim? Oh, Mike. Mike.
Okay, thank you. Better than I felt this time next week when I was in jail with COVID. Still trying to get over the last little bits of it, but doing much better, but nothing much to report.
Okay. Next on the list is Jay Kennedy. Go ahead, Jay.
Well, good evening, everybody. I'm just kind of reading the mail at this point in time, and it's very interesting. Thank you.
Very good. And next on the list, Joe, W7LUX. Go ahead, Joe.
Thank you, Dave. It's been pretty busy here. The girlfriend's president of a radio club and desperately trying to get things rolling again. People just don't want to come out and do anything anymore. And we've got a big public service event coming up in a few weeks. The Go satellite reports all sorts of solar activity, and people who were on the air a lot this weekend report lousy conditions. And my grape receiver is picking up at least some of the giving some indication of these flares that have been going on the last few days. Thank you, Dave.
Very good. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I was actually fairly busy this week in the process of moving. I'm currently moved into my new lab, as you can say. I haven't been doing a lot of work related to VLF or HAMSci. What I have been doing, I was working with Joe. Joe has some VLF receivers, some handheld handheld VLF receivers that he was using, and he made some recordings. Joe, I don't have my processing server hooked up yet, but once I get it hooked up, I wanted to run your recording through VT filter to see if I could find and filter out all the power line hum and see how clean I could get it. Once I do that, then I will get that back to you. I was also looking for ELF tails in some elves events. I'm part of a Facebook group that where they post pictures of TLEs, and I tried to see if I could capture the ELF tail from an ELF tail from an elves event that sometimes occurs. Also, I've been working on my presentations for Tapper DCC. That's all I have right now. Back to the net.
Well, very good. And next on the list, let's see, we called on Jules, is Michael Howen, AC0G. Go ahead, Michael.
Good evening, Dave and everybody. Spent much of the week, bigger part of the week, hauling my kid to Cleveland and back to start his sophomore year at Case. Back here at home, I've been learning more about GNU radio, and I switched my grapeless grape system from an RSP Duo to RSP DX. So that's waiting on a Hermes board to show up so I can play a little bit more with that. And otherwise, nothing further. Back to you.
Well, very good. And next on the list is Scotty, WA2 DFI. Go ahead, Scotty.
Can you hear me now?
Yes, we can hear you now.
Okay. It's been a pretty busy week here, getting board testing, serializing and testing done. As you can see in the background of my picture here, that is 500 magnetometer boards all laid out for beginning testing, and takes up pretty much my entire workbench. So I have incentive to get them tested because I can't do anything else until they're all packaged up and gone. So I made arrangements with Bruce to get them put up into the store. So we'll hopefully by DCC we'll actually have the magnetometers up, the local kit anyway, up for sale, the boards up for sale. And let's see what else. Oh yeah, and down home here, I don't know if you can see this in the corner. This is the off-the-shelf kit board and the DE adapter and a clock module up here, and what you can't see on the back is an RF module, loopback. These are both loopback boards. And I kind of went overboard on the LEDs. They don't come through very well here, but the red and green LED down here by the connector has burned a hole in my retina already. Everywhere I look, I see a red LED now. It is so bright. I need to maybe change some resistor values or PWM it or something. But so the idea is this is running a loopback test. So you see it's flashing there, and what you don't see is down here the LEDs for the test. And I've got a force test fail here. So you can see that LED come on. I don't know if it comes through very well.
Yeah.
Off, on, off, on. So the idea is I'm using the boards on the off-the-shelf development board as error indicators for the loopback test. So I broke the loopback path up into 4 paths, and 4 paths of ins and outs. And I have a rotating pattern on the outs, and I look to the in to make sure it matches at every step of the rotation. And if it doesn't, then I latch that and light an LED says, oh, it's failed. So the idea is that the next day or two, I should have all of these adapter boards tested to verify that they work, and we can start shipping them out to people who have boards that want to test. And we'll pair them up with RF modules and clock modules. And also I got the other GPSs, the 2 lower cost GPSs for the clock module, because we built them with the what are they called, the F8s, I think. Help me out, Dave.
Yeah, I think it was
The 9s are the good ones.
F9Ts, I think, is what
Right.
Oh yes, that's what John was using.
And anyway, so we actually I bought the NEA modules, and it says that I think there's an M8N and an M8T are the two. Anyway, there's the $20 level, there's a $60 level, and then there's a $200 level. Okay, we built 23 of the boards with the $200 GPSs on them. The last 2 boards I saved out, and I just ordered the lower 2 cost modules, where I'm going to solder those on and send all 3 of them to John with a DEA. And the DEA is rigged up so you don't need an FPGA board, because it's got a USB port on it and 2 I2C ports. So he's going to hook the I2C ports up to his Arduino, and he's going to hook the USB port up to his computer, and he's going to be able to program the clock modules to do some testing on those before we really get started. So we're going to have to really come up with an initial load of that before we can really run the data engines. So anyway, so let's see what else. The real data engine scheduled to be here the day before I leave for DCC. So I should have a real data engine with the Max 10 on it to bring to DCC to show off. That'd be the first hardware sample, but It's finally, after what, a year and a half of waiting for the
Yes.
FPGAs, we finally get the boards. So and I'm trying to think what else. So I'm, like I said, I've written a loopback test to test these, and we'll need a different loopback test to test the actual data engines with the loopback boards. So, but if you can see on the loopback boards, all these LEDs, it just shows up as a big blob here. But what I did was every power pin and every ground pin on the loopback boards has a separate LED on it. So this tests the continuity of all the ground pins and all the power pins to make sure they all are good. And then, of course, the data pins connect to other data pins, and I can stimulate those and then read back the result and verify that, in fact, both the IOs are working on the FPGA. So I can't test everything because the boards are really designed for the DE board, but I could test almost everything, maybe down to 4 pins or 6 pins I can't test. So it's will be good enough anyway to get people going and go from there. And I guess that's about it for now. I've got some pictures here that I'll be happy to share on my screen when we go into the regular session. As for that, back to you, Dave.
Okay. Next on the list, I believe, is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave and the group. Been a busy week. I started trying to write Verilog code that since I'm a complete newbie at it, it's pretty much a disaster. I sent an email to Scotty. He gave me some real good answers. You know, what's the right way to structure Verilog for modules? That all made sense. Scotty, thank you for that. That was a big help. I tried creating a new top module and demoting all the QSys Ethernet IP down one level and invoking it with a Verilog statement with no parameters, hoping that it would pick up all the defaults, and complete disaster. So QSys errors out on all kinds of DDR3 IO pins not wired up right, and all of that just from moving the module down a level in the hierarchy. So I sent you an email with an error message that I can't read very well, but we can talk about that later. That's probably a bit detailed for the call tonight. Back to the group.
Very good. Well, at least it sounds like things are progressing. So have I called on everybody on the list? Oh, Jay.
Hi there, everybody.
WB8 SBI. Go ahead, Jay.
Oh, thank you. Joined late because of computer problems here. So I'm going to have a conversation up close and personal with this machine once the group is done. Looking forward to DCC, have hotel and airline reservations made, and just deciding if I want to rent a car and go exploring at night or take my chances with hotel food. So otherwise, looking forward to everybody and hope everybody has a good Labor Day weekend. Are we going to be holding a meeting this coming Monday on Labor Day? Is this group going to meet on Monday, Labor Day?
I don't know. Nathaniel, what do you think?
This is really more of a Tapper thing. So if Tapper wants to take the week off, that's fine with me.
Yeah, I think Dave
Yeah.
to me that we took the week off last year.
Yes, I think we did. We
Yeah,
usually take it off if there's an actual holiday on the day.
Yeah, I would certainly be in support of that.
Yeah.
Okay, that's a plan.
Okay.
Otherwise, just have to send my Yaesu rig back to Yaesu for service. So I'm waiting on that and just looking forward to the DCC. Take care, everybody. 7-3. Good luck in the contest and happy Labor Day holiday. Back to net control.
Okay. So I think that's everybody on the list. So we're open for general discussion.
Say, Tom, do you want to archive the project, and hopefully it'll be small enough you can either email it to me or you can do a Dropbox,
Yeah, I've got a tar of it on Dropbox. You can just untar it.
Okay,
And then you have to edit one line of text in one file because it puts the absolute path in. And so you have to edit an XML file to put the path name on your computer in it. But it's just one line of text. It's real easy.
so which file is that? I've never had an issue with that.
Okay, it's the board support package, the .bsp file.
Okay,
What that file does is when if you make any changes to the QSIS, you have to resynthesize the HDL, and then you have to regenerate the software board package from the new HDL. And what it does is it writes it to an absolute address. So if you carefully got a working directory version and then copied it somewhere else, you just blew up your past working directory rather than the new place you just moved all your code to. So you have to hand edit one line in that file. I'll give you the information about the line to edit, but I tried to make the simplest possible change. Just demote the top block one level and call it with no parameters. That's all I did. A 3-line new top block. And boy, what a spectacular down in flames the compile on that. So maybe the naming IO pin hierarchy changes. I don't know. I just don't know enough about Verilog. The email you sent me was really good. That helped explain what's the right way to structure things. Makes a ton of sense. So that answered just a whole bunch of questions. Really appreciate that response.
okay, no problem. Sorry it took me so long to get back to you. Things are going crazy around here trying to sell the house and do all this stuff at the same time.
Yeah, and then get ready for a DCC on top of it.
That's right.
Yeah.
So what I'm thinking though, as far as your error goes, it looks like it's IO block errors, which means that you may either have to instantiate some IO blocks for that RAM on the top level that it took care of before, or maybe it's trying to do it on the bottom, inside the QSIS level, and it's not supposed to be there when you move it, when you drop it down one level. It's the only thing I can think of. What you might try to do is, if you have the code, and see, this is one of my problems too, is that the code for the development board that has RAM in it, that has DDR3 RAM in it, it uses the QSIS block as the top block, which is not the right way to do it if you want to ever do anything else. Now, maybe it's easy for the guys writing the code for the board, but if you really want to add any Verilog code anywhere, it makes it almost impossible because there's no top level to put it in. So,
so my thought was, I like the way you define structuring it. If I can't get that to work, before I did that and I left all the QSys at the top level, of course, it all builds correctly and runs and everything else. So no changes to QSys or HDL or anything.
yeah.
But what I'll do is I'll leave the old top block in place. I'll write all the new Verilog like it's a top block, but I'll get it into the existing top block by a single tick include statement. And that way I don't have to mess around with the existing top block. So I'm going to try a workaround if I can't figure out what basically the right way to do it is, which is how you described it.
Okay, I'm skeptical that what you described is going to work, because you're going to end up with duplicate references, and I think you're going to have a lot of trouble with that.
Okay. Well, yeah, if we could figure, the existing top block basically has got instantiates the Ethernet controller and the IO, and then instantiates all the QSys blocks. And that's
is there more than one QSys block?
Well, it's a bunch of sub blocks inside QSys.
Okay, but all you do is instantiate one QSys block, and all that stuff's down inside of it.
No, the current top takes care of all of that. However, Altera wrote the design example. There's a ton of QSys instantiations inside of it.
Well, okay, but
also,
you open the one QSys file that has all of the RAM and the NEOS and all that inside it, correct?
No, no, I don't touch that. The design example puts the Ethernet MAC and then all of the QSys stuff inside the top block. And there's about 10 or 12 QSys instantiations in there.
Okay, but so they use a QSys top block, and then in that top block, they have multiple QSys instantiations too?
No,
Okay, because I'm not clear on how you can instantiate something, a QSys block inside a QSys block. Normally, you would have a top level, which would be Verilog, and that block you would instantiate one or more QSys generated blocks.
okay, let me go bring up their Verilog code. And
Of course, the normal way they did it is they have a QSys block as the top level, right?
okay, they
So
do
there's no
have
way-
a, they, okay, they do have a QSys block inside the top block. And then it sub calls out a ton of other things, but it's all in one flat file.
Okay, but is the top file a .v file or is it a QSys file?
It's a .v file. So what they do is they make the Ethernet controller block the name of the top block. That's the Ethernet MAC is the name of the top block. And you call it with the parameters. And then after that parameter list, it goes into all the QSys stuff and it's all in one flat file.
I really wish they get some programmers to write these things instead of, or maybe some hardware guys instead of some programmers. This
Okay,
sounds like a real mess because the way, I mean, I like a nice clean hierarchy, a Verilog top block. You instantiate one after the other QSys blocks and you edit each one of them within QSys independently. They each have their own parameter list and you connect them up on the top level with wires basically.
okay. Well, what I'll do is I'll send you a link to my Dropbox
Okay.
that has the currently working archived DELH load for the FPGA. And that works with Ethernet UDP packets. And it's about half the protocol that's implemented. That works. And all I did was add tangerine_top.v and make it the top level entity. And it has one call to the Ethernet controller with no parameters. And that's what
Ethernet controller
completely
being-
blows up.
Ethernet controller being the previous top block.
Correct. Right. So I call that one previous top block with no parameters, and that's the only statement inside of my new top block module. And
Okay.
QSys just completely errors out.
And I'll show you some techniques I use when I instantiate things too, which helps a lot on making sure they get connected up right.
Yeah.
So what I do is when I instantiate the things and you instantiate the pin names,
Yeah.
the preceding dot.
Right.
What I do is on the line, I put everyone on a separate line and I put a comment over to the right saying whether it's an input or an output and how wide it is. That
Yeah.
way you don't have to continually flip back and forth between the two and say, well, wait a minute, now was that 8 bits wide or was that an input or I can't remember what that is.
Yeah. Their top block looks very similar to that. They did comment a lot of those things. But what I'll do is I'll send you a link to Dropbox where the tar is. And you can look at their top block, and it's not called top. It's called, RGM M10_RGMII for max 10, reduced interface gigabit media independent interface.
And it's a .v file that they
And
create.
it's a .v file, and it is the top block.
So now what you've got is a top block that's the Tangerine.v, and then
Yes.
you instantiate the RGMII.v inside that.
Yes,
And then everything is inside that RGMII block because that used to be the top block. So
correct.
anything-
I made no changes to the RGMMI file. All I did was instantiate it from a top block, and nothing compiles.
yeah. Yeah, I tell you, I ran into this problem last night with the when I changed the pins around on the. I had some errors on my pin list for the
Yeah.
loopback test, and so I moved the pin lists around, and I recompile it, and it gives me an error, and it says pin list conflict, pin conflict. And it says can't move the pin from, and then it lists my new location from the previous location. And I'm going like, where's it getting the previous location from? In the pin planner, I changed the location. Okay, so it's not, well, what happened was the incremental recompile was turned on, and it was set to preserve all of the pins. And so you had to go, I don't know how that got turned on. That was by default, but I copied this from a different project, so that it was probably on there too.
Yeah.
Anyway,
Well,
that was a fun time.
My guess, one possibility is that now that QSYS is no longer in the top block, then the hierarchical pin names might all change.
Right.
Because instead of being just the QSYS block name, it might be the new top block dot the old QSYS name.
It will be that way. Yeah.
And therefore, all of the IO pin names on the FPGA are now all wrong because they all have to be changed. And, you know, it may be something like that where we just have to go back and edit every IO pin name or pass all the pin names as parameters. That's what I was worried about, having to pass, you know, having a top block with one call with like 600 parameters in it.
Well,
So-
did you make sure to turn the set the compilation setting for source code so that it doesn't try to preserve anything?
I have no idea what that is.
Okay, yeah, I'll send you an email. You have to go into the partition editor, and you have to turn off the compilation. It's basically the place it starts compiling, and you want to do it from source code, which means it starts over from scratch every time. You don't want to preserve anything. For what we're doing, we're moving too much stuff around and adding stuff. We want it to start over. And what it does is it increases your compile time, or it doesn't decrease your compile time when you make small changes, but it doesn't give you these errors with locked pins and, you know, and it should regenerate all of those names if they're linked properly on the level.
Yeah, well, I'm worried there might be, you know, there's an existing pin file, text file that says names all the IO pins. And I'm wondering if that has to suddenly change because all the QSYS is now one level down in the Verilog.
That's all stored in the QSF file.
Yeah.
But I'll warn you, you probably know this already, don't edit that file with Quartus running, because it opens the file, and when you exit Quartus, it writes it back. So if you open the editor and you just lost all your changes.
Okay.
And the other thing is, the best way to edit the QSF file is to go into the, not into the pin planner, but the property, I think it's called the properties editor or the pin editor. There's two ways you can edit pins. One shows you a graphic of the device and you get to see the fields, and you can do most things there, but when you go into the pin properties editor, it lists the properties out of the QSF file. So you can delete ones and they actually go away instead of just like somehow being relegated to a second class status and then coming back to bite you later.
Okay. Well, very good. I'm trying to quickly get something up and running so I can bang I2C bits and things like that.
Because we're going to need to bang IC bits to get the clock module set up to generate the right. I'm going to get the list of parameters from John Ackerman, so we'll have to put an I2C master in the FPGA to bang that out to the clock module to get the right clock frequencies.
Yeah, so I built, the image I built's got 5 I2C and 1 SPI block in the QSYS.
Okay.
And that's what I was trying to wire up. And it's been, you know, last week it was total ignorance of Verilog, and now I'm up to about the F- level of Verilog. So there's a little bit of work to do.
Well, I see you finally noticed I put the Altera, the pin names, pin numbers in the schematic.
Yes, I did. I started a spreadsheet, and then after I got it done, I noticed you had already done all that work. And so ton of time saving. At any rate, we have a suspicion. I'll email you the link to Dropbox. You can pick the working design up, and you know the changes I made are pretty minor. Do you want me to tar up what I changed and broke, or do you just want the working one?
Because I'll look at the working one first, and then I'd like to see the change you made, because it might jump out at me what the things that have to be fixed there
Okay,
by demoting it. And then
very good.
also,
I will, okay, I'll tar up both versions and send you a link.
okay, and by the way, on the schematic, the pin numbers of the FPGA are correct. But if you
Mhm.
remember, I had some text on the outside on the lines on the nodes
Yeah,
that corresponded to the name of the signal on the RF module.
yeah.
Those are incorrect. I've gotten some pluses and minuses reversed.
Ooh,
So
okay.
don't use those names. So I spent the last 2 days tracing out traces on the board because it's got to go from the RF module pin through the MEC connector. Then it has to go through the dev board. Then it has to go through the HSMC connector, and then it has to go to the FPGA pin. So I've got and I could show you that code if
Yeah.
it's interesting to you. But
That's what I did in my spreadsheet, is I traced out all those connections all the way in the
And-
spreadsheet.
also, what you're going to find useful is the header out of my loopback file. I list all of the pins that connect to the RF module and connect to the clock module, and I put the FPGA pin in the comment field.
Mhm.
And then not only that, I put the FPGA pin, I put the MEC pin, I put the HSMC pin. So I basically got the flow in the comment field because I was making so many mistakes trying to trace those out, in my head. I said, okay, finally, I'm just going to write them down. And that
Yeah.
way now I can just look at the list and I can figure out how the signal flows from the RF module inward.
Yeah,
So-
I took the one page of the board, and I don't know if this will show up, but I couldn't read it on screen. And so I did a cut and paste, magnify, sharpen, and then print it out. And that and a magnifying glass, I'm able to read it. So they're tiny, but at any rate, they looked, when I did the first pass over, and they looked correct. But I didn't check for polarity reversals.
Like I said, the only thing that's not correct is the text that's in black or gray.
Yeah.
All of
Okay.
the interconnections that the netlist got, they're all right.
Okay, yeah, I don't think I looked at the gray because it's so difficult to read.
Yeah, I found myself using that and I got in trouble because I got a bunch of bits flipped. So
Okay. Anyway,
I was gonna fix it, and then I thought, well, no, wait, I'm gonna have to change the rev of the schematic if I fix it. So we'll wait to do that to see if there's any
Okay.
problems.
Very good. We'll try to make the way you structured the code work. If I get desperate, I'll do a hack attack on the code and essentially use an include to build one gigantic top block and see if that works.
Well, like I said, I see no reason to make sub blocks unless you're planning to reuse them.
Yeah.
And if you use them once, that's okay. But if you want to reuse it on the top block and then multiple times, and then use it on lower level blocks, make a separate block and use it everywhere. Don't try to use top level blocks. So what's going to happen is that I've worked on projects where there were 23 different files. And what the guy did, so I inherited it, right? It was something that we had to make work. And the guy would put multiple functions, multiple modules in one file name. And so then he'd call that function and you'd have no idea what actual file that code was in. And yes, I know the tools can help you there, but it really, to wrap my brain around it, it really gets hard. I ended up having to draw hierarchical diagrams to show where the functions were in what files so I could find them and work on them.
Okay.
So I think it's much better to just have module name, file name, the same. When you look at your list of files, you look at the list of functions. Files are free, disks are big. Making the organizations better than the obfuscation.
Yeah, in searching Google for the error message, it turned out Quartus changed how they handled bidirectional IO pins about version 12 or 14 or something like that. And stuff that used to compile doesn't compile in later versions because of they changed how the Verilog works. And so it was off to YouTube to find out how to do bidirectional IO pins in Cordis. And there's a few videos out
So
there on how to do that.
Which version are you using of Cordis?
20.1.
Oh, good. That's the one I'm using too.
Yeah, that's the last version before the UDP socket library gets blown away.
Okay. And you know, I'm still working on projects on 17.1. So
Uh-huh.
even though they don't support bugs very well for older versions, once you get it working, then at least it stays working instead of breaking a bunch of stuff.
Yeah, in going through all this, the software generation was painful. There are a lot of issues in the NIOS toolchain. The Cordis toolchain appears to be a little bit better behaved
Yeah, Neos has always been
than the NIOS tool.
It's there. I call it Neos, but it's
Neos.
been
Yeah, it's about 50-50 on the internet.
yeah. But we're gonna have to start calling it fear filters in respect
Fear
to
Filters, yes.
Yeah, somebody will be looking up FEAR filters.
That's right.
All right. So anyway, so it's been an interesting week, and we'll resolve. I just, the gut feeling is just it's a hierarchy naming change that happens. But I suspect if you look at their old top block, you know, you'll probably figure it out in 2 minutes.
Okay, I hope so. You don't want to spin your wheels on something that is just a syntactical thing instead of a functional thing. And so when I get this board set ready, is it set? You have a development board, right?
Yes, that's what I'm testing all this on.
Okay, good. So this will plug right on there, and
Okay.
you'll be able.
Yeah,
to
the intention is to get the Kong was going to do the SPI normal to analog devices adapter, but he's been out, and he said he's not going to be able to have time to do that. And so I was going to, once I got the I2C working, I was going to try to figure out how that worked and build the Verilog to make the standard SPI.
Well, I've written a 5-wire before, but it's a four-wire one, so it should modify to a 3-wire one without too much trouble.
Yeah, to make matters worse, QSYS calls the 4-wire SPI. Their name for it is 3-wire SPI. And and so I guess the analog devices should properly be called the 2-wire SPI.
So by 3-wire, they mean MOSI, MISO, and clock, right?
Yes, that's what they mean.
Even though there's a chip select, which is the 4th wire.
Correct. And so the 3-wire really means what the rest of the world calls 4. And so that has to be adapted down to what I guess we'd have to call a 2-wire. I don't know.
Yeah, that's just because the data is bidirectional, right? So it's
yes. Right. And so it's not obvious how to do that. Kong looked at it for a while and threw up his hands. And so it's going to take some time to go figure that out.
Yeah. Well, maybe I get a chance to take a look at that, although I'm pretty booked up here trying to get this hardware out.
Yeah, if I can get anything to compile and bits to come out of I²C, I'll probably have enough confidence to tackle the SPI interface.
Yeah. All right. Sounds good. Making progress. And let me share my screen here for a second if I can. Okay, this is the adapter board on top with the clock module in the lower left with the massive LED beacon. And so what you see here is blue lights here on the top two, and then a red light on the bottom.
Mm-hmm.
This tells you what the VCCIO is set to. Blue is 3.3. The yellow, which you don't see, is 2.5, and then red is 1.8. And there's 3 VCCIOs, so there's 3 separate comparators that will tell you how you've got your data engine strapped before you plug in your clock module and blow it up by running it at 3.3 volts. And then each of these yellow LEDs here along the right-hand side of the clock module, that's a separate VCC pin. So, and the 2 that are out here, you can barely see them, just below the top ones. That's for the USB because I don't have a USB loopback plug plugged into this USB port over here. So they don't show up. So I'm not testing those. And then just for you, Jonathan, over here, this connector is for your TI analog board that you're using for the VLF breadboarding or testing. So it'll plug right on there. And then again, you can see the connector here of the RF module, but it's a loopback board and it just feeds back a bunch of data so I can make sure that all the interconnects between here and the FPGA are good. And then let's see, I got another one here. This is all of the boards. DE adapters here, clock module loopbacks down here. You guys can see my cursor, right?
Yes.
Yes, it lags a little.
Okay, clock modules up here. This is these two here and these three over here are leaf loopback modules, of which I don't have any use for until I get a real DE board. Then up here, these on the top are RF modules, 25 of them. And then the remaining 10 are RF module loopback boards. So, and I got those to be able to test the data engine, but it's useful for testing the data engine adapter also, just to make sure that I don't send you guys out a board that has dead traces on it or something that where you'll be scratching your head for a long time trying to figure out why it doesn't work. And then right here, you can see these are the OLED displays that I frivolously put on the boards just to have something fun to play with. So that may be the next thing that I waste time on trying to get that working. I just want to light it up, maybe put a picture of a tangerine on it or something. Something that looks interesting, that shows that it's a display. Right now it looks like just a black window. And then one more thing I've got. This is what 500 clock module or magnetometers looks like. So this back block right here on the top, that's 250 of the local boards. We actually had the manufacturer leave off the serial, the 7-pin headers for the magnetometer board, because you don't need the magnetometer board on the local end that plugs on the Raspberry Pi. And people were saying that it's hard to get the soldering iron in to solder the 40-pin connector with that 7-pin connector in the way. And they cost $1 a piece. So we said, okay, let's just lose them on the local end. And then, of course, you heard this story about how we didn't have enough temperature sensors. We couldn't get enough to build all 500. So we left the temperature sensors off on the local boards. So these up here on the top have no temperature sensor on them, and they have no connectors for the magnetometer module, the PNI module. And these down here, these 250 have both of those things on them, and none of them have either RJ45s or 40-pin headers. They get soldered on by the user. And yep.
Yeah, it sounds great.
And then let's see what. So what we did is we serialized all these with serial. We hadn't finished these when I took the picture, but they're all done now. And we put an L suffix on the local end boards and an R suffix on the remote end boards. So the idea is, Jules, if you're going to make instructions up on how to modify these boards, you can refer to the R board and the L board because they got serial numbers on them that end in R or L.
Yeah, good. That's going to be handy.
So you can say on the L board, you can put the 40-pin connector on. And on the R board, you don't have to put that connector on, but you'll have to put the RJ45 on both. And then my suggestion, if you're writing up instructions on how to do the magnetometer, see if I can, how do I get rid of the share here? Stop share. So the kit of parts consists of 2 RJ45 connectors and a 40-pin long tail connector, 2 7-pin little headers, the PNI board. Now this one has the jumpers already on it. The headers already on it, but the board that comes from PNI does not have these headers on it.
Right.
So what I recommend is that you take the board and put the headers in. And then you take the P&I board. You put that, if I can see that, I don't know how I can do that. You can put the headers in and put the P&I board on and use the sockets here as a guide to make sure that the pins are vertical.
Yeah, that's the way I usually do it anyway.
Okay, okay, good. And then we also include one 2-pin header, 2-pin jumper.
Right.
For hooking the shield on one end, because we said we were only going to do it on one end, right?
Well, I'd prefer to have possibility to do it on both ends.
So
I mean, I'm doing mine on both ends. You don't have to, but I mean, to leave the option open would be good.
Well, if the option's there, it's just that right now I was only including one jumper. We can include 2 jumpers if you think it's useful.
Yeah,
would send
I'd
2.
throw a second jumper in.
Okay, because the idea is I don't want to include any parts that is not used for the standard installation.
Right.
They're
For
there.
RFI, you really want it jumped at both ends.
Yeah, but mine are all jumped at both ends.
Okay, so we'll put 2 of them on there.
Yep.
And then, and by the way, the header here is, this is a tin one, but ours are going to be gold.
Okay, good.
So again, I can send you this kit, Jules. I don't have all the parts for I don't have the gold one, and I don't have I don't think I have another P&I board without the headers installed. So, but I can send you this kit.
Yeah, I have a P&I board without headers, so I could use that for the illustration.
Okay, so I'll send you the headers too, so that you
Sure.
can see
Yep.
that. And then an R board and an L board. And you should
Sounds
be
good.
okay.
Yeah.
And I think I have your address from before, so.
Yeah, it hasn't changed, so that should work. If you don't, let me know.
Okay. All right.
Just a quick question. Did you have a chance to review those photos I had on assembling the waterproof connector?
Yeah, and they look pretty good. I had this fantasy that I'm going to find a connector that I can screw in. And it turns out that I can find a bulkhead connector with it's a BSP thread. And now it turns out what they say is the BSP thread and the PF thread are the same. And they said a PF thread will thread into an NPT thread with a tight fit. It's not quite right, but I like your idea of gluing it in. So what you do is we can put epoxy on it and then screw it in.
Yeah.
And it won't quite fit right, but if you torque it down tight and use the epoxy to fill in the gaps, I think it'll be the best solution. And that way you may be able to just do it without having any drilling at all.
You still have to get a hole, right? I mean, you still have to do the hole for the, yeah.
No, because you thread it into an ST fitting.
Oh, I'm sorry. Okay, I got you. Yeah.
And then you glue that fitting onto a pipe and stub, and then you glue that pipe stub into the T, and
Right.
then a couple extra gluing steps, but because I think you're going to need more space than the T is going to give you. You're going to have to extend it out. Because when you thread it in, I don't know, and especially if you thread it right into if you got an SST T that's threaded on the side.
Yeah.
If you were to screw that in, you'd never be able to unhook it because
Right.
it's down inside the T.
Right.
So you really need to put it on an end of a pipe and then RTV one of the 2 pipe joints so you can take it apart.
So again, is that the same connector, but
It's not.
it's not? Okay.
It's a different one. So I want to make sure I get a shielded one because there's a whole ton of non-shielded ones.
Yeah, I know that's the problem. And some of the ones that are shielded, the connection is actually quite poor. It depends upon the metallized shell, which just does not work. I had one of those and it fails after 3 or 4 months.
Okay, and that's to make the connection between the male RJ45 plug and the shell itself.
Yeah.
And then on the inside, it does the same thing. So to
Yeah.
get the shields connected together. Well,
Yeah.
so how do they do it on the high quality ones?
Well, the high quality one, basically they have the shield is connected via it's a direct, the female to female has the shield built in. So it's just a shielded female to female connector, and you take a shielded RJ male on both ends and push it in, and you got a connection through with the shield.
But there's no pin in the RJ45 for shield. It's
No,
the
but
shell, right?
but it's a shell, right? So it's basically the shell.
But the shell just has spring scrapers that rub against. Okay.
Right, that's all you need.
So that, so then how did the other one connect the grounds?
I'm sorry, I don't know which other one.
So the one that was the poor quality one that you said failed after a while. How did-
Okay, that one had a metallized, it was plastic. It was a metallized shell, which actually then was the shield connection, which supposedly mated with a metallized plastic spring-loaded contact on the inside of that, which worked for a couple of times and then failed.
So it wasn't a metal spring then, it was.
Right, the present unit that I'm using, the Syrexian unit, is really positive, and the watertight seal is excellent.
Okay. So, yeah, I'll keep an eye out for that. I still have the fantasy that we could do it without drilling, but you
Well,
know,
but the other piece is that I was looking for a mate, because the thread on that connector is very close to a metric. But I haven't found exactly the diameter tap. Of course, the problem is that the metric tap costs you about $40.
yeah.
But
And now, did you know that you could buy, I believe you can buy metric tapped PVC, but you got to buy it from a place in Europe, which
Yeah.
is, so we could, if we bought, 500 of them, that is certainly a possibility, but that would mean you'd have to use our kit
Right.
to do it.
But I figure, if somebody's going to put together one of these pipe assemblies, then they've got enough tools to do what I did with that epoxied connector.
Yeah.
It's not that big. It took me an hour's work to put that thing together.
Yeah. Yeah, no, and I don't think it's that challenging for the average ham, but would be much easier to not have to drill if it's possible. It may not be that we can do it, but I really like the idea of your gluing the connector in. That really made a lot of sense.
That's a really solid, there's no leak, no possibility, doesn't move. You can,
Yeah, and
great.
it doesn't have to fit exactly tight because the epoxy fills the gaps, and
exactly.
you don't have to get it down inside there and try to screw that nut on or grind the
yeah.
corners off or whatever.
Yep.
Because I was thinking of, well, let's use a 2-inch cap, and then we got to use a reducer, and then that's messy.
Right,
So,
it does. Yeah, it does.
So always on the lookout for a easier way to do it, but it may end up that I just give up and use your way because you got it all documented, and it's like, okay, that works.
I agree with that, Scotty. I think Jules has got a good way, and there might be other ways, but we can leave those to another revision.
Yeah, and also we can suggest that if someone else who's assembling one of these has another way, or just happens to have the special taps or whatever, let us know, or let the group know, or maybe a different style connector that you found that works just as well. Hey, communicate it and let the group know.
Well, the other thing that we could do is we could pre-drill the cap.
Yeah.
And then there's no drilling. So
exactly.
Take care of that. And that, especially now that you glue it, you don't even have to grind it off flat, do you?
Well, I mean, the only reason I did that is it still makes a little tighter bond, and it was just the purist in me says try to fit the hole to the shape of the shape of the threaded connector.
And that's one thing I hate is that D-shaped, double D-shaped hole.
Oh God, yeah.
So you have to do that, right? There's no way you can just use a drill and make it round. And
well, you can make it round because it's still the flange, the top flange is still fully round. It's only the threads that are flatted on both sides. So you could fill that in with epoxy.
Okay, so you drill a 28 millimeter hole instead of a 25.
Right, exactly. Yeah,
okay.
That would work. In fact, I could do one of those just as a one-off to compare if you want to do it that way. Sure.
Yeah, that would be easier because then there's no filing or anything, and yeah,
just zip and you're done.
Yeah, and then since you have to glue it, even if you're a little off center, it would work great.
Right. Oh, it'll still be on center. It's just that you can rotate with the way I do it right now. You can't rotate it even if it's not glued.
But once you glue it, then you can't.
Yeah, you can't rotate it either. So there's no reason not to do it that way. But yeah, let me do one off like that with just a straight round hole. And then it makes it easy, no filing, glue, trim off the any stuff left over from the drill, and then clean it with alcohol, then epoxy, and you're all set.
Okay. And then, and you use a pilot hole, right? So even if you're a little off on your pilot hole, since
Yeah,
you're doing it, it won't make any difference.
Exactly. You can be a bit off on your pilot hole and it's still fine.
Yeah, yeah.
And also you don't have to get rid of the printing on the face. If it's a flat face or a printed face, doesn't matter because the epoxy fills it in.
Yeah, yeah. And then did you say that you used the channels? I saw you use the channels and glued them to the pipe. Is that the way you're going to do it, or you have a different way? For putting the board in the bottom of the pipe.
No, the way I do the board in the bottom of the pipe is just with slide it in, orient it. I mark the pipe so I know what the orientation is.
Right.
Slide the board in and then use the foam to hold it in position, and then assume that it's going to stay there without any additional assistance.
The picture you showed, I thought I saw, was you had the two U channels that were.
Yeah, I did, but that was only to demonstrate the foam, and I did make a note on that saying, you know, we won't have the channels in the final product, but this is to show how the foam packs, you know, basically keeps it against the wall of the pipe.
And are you using the round pipe insulator foam?
Yeah, I just happen to have a picture of whatever I had.
Oh, okay. Okay.
But the final will use the foam we're talking about.
I can send you a picture of the foam insert one if you don't have one.
Actually, I have it. I have the insert.
You have it? Okay.
Yeah.
Okay.
I have 6 feet of it.
Okay. And it costs like $1.05, I think.
Right. Yeah.
It's like nothing.
Cheapest thing in the whole, right.
Yeah, and it'll make, you know, like 25, 30, 50 pieces.
Something like that.
Yeah. Yeah, when I read that the threads would actually mate more or less. They're a little bit off, but I thought, oh, there's hope for all of us to do it the cheap way, the easy way. But maybe I can convince Bruce to drill the holes.
Yeah, if you're going to drill that larger hole, you do need to support the cap, because the torque and the drilling process will just tear it out of your hand.
Right.
You can't hold it.
And actually, is the cap is hex, right, on the top?
I'm sorry, the
cap is round or hex on the flange?
Oh yeah, you mean the step drill?
No, the cap that you're drilling the hole in is it's completely circular. I know it's circular.
Oh, I see what you're saying. Okay, there's 2 types. There's a hex and there is a round. Right. For example, the one, if I go to Lowe's right now, I'm going to find the round version. Okay. If I go to Home Depot, I might find the hex version.
So you could actually put the hex version in a drill press easily, because it's got nice flats to hold it.
Yep.
Okay. Yeah, and I was wondering too, you could drill a pilot hole, or if you have a drill press, you might get a 28mm drill and just drill it directly.
Sure.
If you had a client, what I'm thinking of in terms of if we were to make 100 of them.
Okay, yeah.
Go buy a box of them, go take the drill press out, get yourself a pizza and some Dr. Pepper, and sit there and just drill and make 100 of them.
Sure.
And we wouldn't have to use a step drill. We'd use a straight.
Well, you know, the other thing I didn't try is a hole saw.
Oh, right.
Which is a slow speed, so you don't melt the PVC. A hole saw might do it.
It has a pilot drill in it too.
Yes, it does. That's right. I haven't tried. I've got a couple of sizes. I've got a 1 inch and a little bit larger than 1 inch, so I could try that.
Is 1 1/8? That's 3. That's 28 mil. That would work.
Yeah, 1 1/8 is too sloppy. 1 1/16 really fits nicely.
Because 1 1/8 is useful for the panel meters that go in cars. You know, the digital panel meters that usually have a USB port in them. And
not sure.
Yeah, because I have one.
Oh, okay.
So 1 1/16 would be better. Okay.
Yeah, I've got to look at that again, but I'm going to look at the hole saw, because that's also available in any shop. And if you work it at low speed, so you're not melting the plastic, it should drill a clean hole.
So you might actually be able to mount that cap upside down in the drill press and drill from the back.
Yes.
Yeah. Okay.
With a wood block underneath for clearance.
Yeah. And then because I have my drill press, I have small clamps on the table that I can rotate the table and I can get everything centered just right so that it drills straight through in the
Yeah.
right place.
Yeah, I've got a rotary table with a machinist vise on it, and
Yep,
I
yep.
use that with blocks of wood underneath for clearance and so on and so forth.
Yeah.
So, yeah.
So, because the thing that I see is that there's probably going to be some people from institutions who are going to want to buy this that won't want to assemble anything. So we're going to actually offer an assembled one,
Right.
but they're going to pay dearly for it.
Yeah.
Because they're going to pay somebody at Tapper to assemble it, and
Mhm.
we're all volunteers and we don't work cheap.
Right.
Because I figure if you can't drill a hole and you can't solder, then probably you've got money, so you can pay the extra. You know, because like somebody like NASA wants to buy 20 of them or something.
Oh, okay. Yeah.
They're not going to care. Or a university may be the same way, although they have cheap student labor, right, Nathaniel?
Something like
Puts that
that.
together.
Nathaniel, what one of your people put one together for Human, right?
Yes, that's right.
Right.
Yeah.
And how long did that take him?
It took him probably about a day.
Okay.
He's pretty good.
Did he have a drill press or did he use a hand drill?
I'm not sure what he did. Majid tends to be very good about these things. I just ask him to do something and he does it. And
Then you don't have to ask anymore, right?
Right. So,
I mean, he might have some suggestions for for an assembly procedure when you're doing several of them.
I could certainly ask him.
Several is in 500.
500.
Well, enough for let's say somebody ordered 10 or 15 of them, something of that sort.
Yeah. So some way ask him how he would do this efficiently.
Yeah.
Yeah.
Because the way I figured on the ground side of it, we're probably not going to provide the pipe because we don't want to have to ship that. So we'll provide all of the fittings, and then you go down to your Home Depot and you buy the pipe.
Yeah. I'm actually going to go meet Dev Joshi in breakout room 1. I had just before you started talking with me, I had just said to him in the chat that I'd meet him over in breakout room 1. So we're going to chat about his paper.
Okay, and I need to go anyway. So
Okay.
Okay.
Yeah, and I need to go too. So thanks, Jules, for all.
Good night, everybody.
Yeah. Thanks, Scotty. Thanks.
All right. 7-3, everyone.
Good night.
7-3.
73.
Jonathan, you still there?